Hi students, today we'll discuss problems on reflection of light at curved surfaces. Before we start problems, I would like to write all the formulas related to reflection of light at curved surfaces. And the formulas are, first formula is mirror formula. Mirror formula. 1 by f is equal to 1 by v plus 1 by u. Second one, magnification. M is equal to height of the image by height of the object, that is in terms of heights, and in terms of distance of the object and distance of the image, M is equal to minus image distance by object distance. Nothing but M is equal to minus V by U. So these are the two formulas what we have for finding out the magnification of the image formed by either a concave mirror or a convex mirror. And this is a mirror formula which can be used for both concave mirror and as well as a convex mirror. And after that, before starting the problems, even we need to have some idea about sign conventions. Okay, used. What are the conventions used while doing the problems related to reflection of light at curved surfaces? Now, I hope you all copied these. And next, now sign conventions in terms of a concave mirror. Now, what are the conventions used for concave mirrors? Concave mirror. Okay, in case of concave mirror, the conventions used are object distance. Object distance is negative, that is minus u. It is a negative because I will explain about it what is the reason of taking a object distance as a minus. And next one is image distance. Okay, is negative. Okay, that is image distance is negative when it is means if the image is real, that is the image that can be caught on the screen. Okay, then the type of image is called as a real image. So in case of real images, the image distance will be taken as a negative value, negative. Okay, and the sign used is a negative here. And image distance is positive if the image is virtual. So as we know, only in one case the virtual image is formed by the concave mirror. The case is if the object is placed between pole and focus. If the object is placed between pole and focus, then only the image will be virtual. In that case, we are going to take the image distance as a positive. Sir, we are unable to understand this one clearly. Can you show in a diagrammatic way how it is? Means, so for a concave mirror, now if this is a concave mirror, this is a symbol, and here this is a pole of the mirror, as usual this is a focus, and this is center of curvature. So I'm explaining directly because you all are having the idea, already you are having a much idea about the pole, about the center of curvature, about the focus. Then because of problems, just I want to let you know about the conventions, how we are taking. Now the distances, when you are writing conventions, when you are applying, giving signs to the respective maybe their object distance or image distance or whatever the case is, focal length. Okay, so we should always measure excuse me, we should always measure the distances from the pole. We should always measure the distances from the pole. Now, if the object is placed, for example, I am saying, okay, if the object is placed beyond C, now we are going to, the direction of the light which is coming from the source is, this is the direction, this is incident ray, but we are going to measure the distance from the pole to the source, that is opposite to the direction of the light we are going to measure. Now light direction is like this, but the distance is measured from the pole to the respective source of light, that is nothing but object. The distances measured opposite to the direction of the incident light are taken as always negative values. I hope you all are understanding. Okay, the distances measured, this is the direction of the incident light. The distance is measured opposite to the direction of the incident light. Distance is measuring like this, but the object is like this, and the light coming from the object is in this direction, but we are measuring the distance from the pole opposite direction of the light we are moving. Hence, the distance of the object is taken as a negative, nothing but u. Is it clear? I hope you all are understanding. Next one is now image distance. If the image is formed in front of the mirror on some screen, for example, some screen, white paper, some other screen, whatever the screen you use, it is going to fall on this in the screen if the image is like this here, if it is inverted image. Now the distance we are going to measure here also in case of this image distance is from pole to the image. So it is also considered as a negative value. So we are going to measure the image distance opposite to the direction of the incident light. So it is a minus value. Are you understanding? Okay. Next one. Now if the image is virtual, if it is virtual like this, that is behind the mirror or inside the mirror. Okay. So image distance is going to measure from here to here. Light direction is like this. We are also measuring the image so formed in the direction of the light only we are moving. Light is moving like this. We are going to measure the distance of the image in the direction of the light, that is from pole to the image. So then in this case, if the virtual images are there, then the image distance will be positive. I hope you all understood this. Okay, come on. Next one. Now, sir, what about the focal length for concave mirror? The focal length for concave mirror is, okay, now the focal length for concave mirror is considered as a minus, because what is the focal length? You know, the distance from the pole of the mirror to the focus is called focal length. So we are going to measure the distance from the pole to the focus. It is nothing but focal length. Now light direction is like this. We are moving opposite the direction of the incident light. Then it is considered as a negative value. Then the focal length is negative for concave mirror. Is it clear, all of you? Okay, next, after this, how we have to take this sign conventions in case of a convex mirror. For a convex mirror, the sign conventions are as follows. Now this is a convex mirror. Okay, we know convex mirror is a what mirror? Diverging mirror. Now this is a pole of the mirror and the focus is in the mirror, that is focus, and the center of curvature is here, for example. Now the source is kept here. I placed some source like candle in front of the convex mirror. Now I want to measure the distance. No, candle is light, considered as a light source, which is nothing but an object. I placed this light source, nothing but a candle here in front of the convex mirror. And here if you consider, this one is considered as a coated surface and this is a reflecting surface. Now I am going to measure the distance, okay, of the source. Okay, nothing but here I am considering as a candle, which is a light source. I am going to measure the light is coming from the, okay, the light is coming from the source, okay, is going to fall onto the reflecting surface of the convex mirror. Now I have to measure the distance from the pole. Always the important point which you have to remember is you should always measure the distances, whether it is object distance, whether it is image distance, whether it is a focal length, whatever it may be, it should be always measured. Okay, from the pole of the mirror to the respective object or the respective image. Now, if I measure the distance of the object from the pole of this convex mirror, and the distance will be considered as a minus, that is object distance is minus, that is object distance for, okay, for convex mirror is minus u. And next one is you take consider. Next one is here how the image distance is. Now, if I place the object here for understanding purpose, I am saying you, if the image is formed here between the pole and the focus, for example, and image is formed in the mirror, that is behind the mirror, within the mirror, okay, and the distance is from here to here, you are going to measure. I am going to measure the distance of the image so formed from the pole to the image. I am going to move in the direction of the light, not opposite. We are moving in the direction. Light is going like this. It is going to hit the reflecting surface. Okay. Now we are going to measure the distance of the image in the direction of the moving in the direction of the light. That is, image distance is considered as a positive. That is in case of a convex mirror. Now next one is image distance is considered as a, that is my plus V. I hope you all understood. Next one, focal length. Sir, how the focal length is measured? As you know well, what is a focal length? The distance from the pole of the mirror to the focus is called as a focal length. Simple definition for is understanding. The distance from the pole of the mirror to the focus is called as a focal length. Now I am going to measure the focal length of this convex mirror from the pole to the focus, and that too we are moving from the pole towards focus in the direction of the light. Hence the focal length of the convex mirror is considered as a positive. Focal length of the convex mirror is a positive. Is it clear? I hope you all, this is small f, you should not use capital F. Okay, focus is capital F and the focal length will be small f. Never use small f for focus, never use capital F for focal length. Okay students, we will continue the problems. Till now we discussed what are the conventions we have to use while doing problems related to mirrors, that is both concave and convex mirrors. I explained already. Mirror formula is 1 by f is equal to 1 by v plus 1 by u. Magnification formula is m is equal to height of the image by height of the object, or in terms of distance means image distance by object distance, that is minus v by u. Next one is if you talk about conventions for a concave mirror, the convention says object distance is minus u, image distance is minus v. Only one case it is positive. I explained very clearly. If you want to revise, just move back and observe that previous video, and you will get some idea. And next one is in case of, this is a concave mirror. In case of convex mirror, object distance is minus, image distance is always positive. And here the focal length for concave mirror, I am talking about here, it is concave mirror. Okay, focal length is minus. In case of convex mirror, focal length is plus, that is plus f. And here it is a minus f. Are you understanding? This you have to remember one case, that is if the image is virtual, and always the convex mirror always forms a virtual image only. So the virtual image only always, hence it is a image distance is always a positive for convex mirror, and the concave mirror always a negative. Only one case exception, that is a positive when the image is virtual. And we're going to discuss about problems related to the concave and convex mirror, that is a mirror formula based problems and as well as magnification based formula problems. Okay, for first problem, now an object is placed at a distance of 10 centimeter in front of a concave mirror of focal length 15 centimeter. calculate the image distance, magnification, and the nature of the image. Okay, and the nature of the image. Now, see, no, this is a, first of all, if you have some idea about the diagram related to the mirror, then this is a concave mirror. If you draw the diagram first, then you will get some idea, basic idea, how to do the problem. Then you should know the formula also. Now this is a pole of the concave mirror, and well, this is a focus, and this is center of curvature. Now according to the problem what was given here, an object is placed at a distance of 10 centimeter in front of a concave mirror of focal length 15 centimeter. Now focal length is, we'll measure the focal length from pole of the mirror to the focus. So that is focal length is nothing but from here to here, small f is equal to how much? 15 centimeter. Now if you apply sign conventions for this, focal length is minus 15, and I was given the object distance is 10 centimeter. So hence we'll get some idea that the object is placed between the focus and the pole. For example, if the object is placed, I will erase this for better view. Now object is placed, for example, here the object. Now the distance from the object, like candle, which is a source of light, okay, the distance from here to here is, that is always measured from the pole to the object. Here the distance of the object is how much? 10 centimeter. That is v is equal to minus 10 it will become according to sign conventions. Now I will write here the data very clearly. Focal length that is given data, that is focal length f is equal to minus 15 centimeter, and next one is object distance u is equal to minus 10 centimeter. Now he has to find out initially, that is image distance, after that magnification, then nature of the image. Now if you know the image distance, then you'll get a basic idea what type of image it is. Now listen, now image distance v is equal to how much? We are going to calculate this image distance. Now I'm going to rub this data which I was given. Okay, now now using a mirror formula. Now according to mirror formula, that is 1 by f is equal to 1 by v plus 1 by u. Okay, now 1 by f is how much? That is minus 15 centimeter. That is 1 by minus 15 is equal to 1 by v. V is image distance we have to find out, and plus u is how much? Minus 10. So that is 1 by minus 10. Okay, now I will rub this. Please copy. Next, now see, 1 by minus 15, bring this plus in 1 by v, plus into minus, minus 1 by 10. Now bring this minus 1 by 10 to this side. 1 by minus 15 plus 1 by 10 is equal to 1 by v. Now LCM is 30. 15 will go in 32 times, that is minus 2, plus 10 will go in 33 times, that is 3, is equal to 1 by v. Now 1 by v, now I will rub this one and I will write at the top. Now 1 by v is equal to minus 2 plus 3, that is plus 1 by 30. Okay, that is, now 1 by v is equal to 1 by 30. Now reciprocal v is equal to 30 centimeter. This is a positive value. That is, I hope I already explained If the image distance is positive, then the image is a virtual. Then we need to think about, we got image distance. Then we have to calculate what is the meaning of what is the magnification, how to find out the magnification. Magnification, the formula for magnification for both concave and convex is the same formula. That is, in terms of distances, m is equal to minus v by u. M is equal to minus v by u. So m is magnification, v is image distance, u is nothing but object distance. Now that is m is equal to minus v is how much? That is minus 30. If we are using minus sign here in the formula, then you have to keep that sign. And v is equal to 30. Now I am going to substitute that 30 here. That is minus 30 by object distance is given already, that is a 10 centimeter. That is minus 10 according to sign conventions. Here minus minus gets cancelled. Now m is equal to 30 by 10 gets cancelled, that is 3. So magnification has no units, that is 3 is the magnification. We can add simply plus 3 is the magnification. Is it clear? Okay. Next we got the value of magnification, and even we know what is the image distance. Now we have to draw the ray diagram to know about the orientation or nature of the image. Okay, for that, now I will draw the ray diagram. This is a concave mirror, and this is a pole of the mirror, this is a focus, and this is center of curvature. Now object is placed between P and F according to the values. Okay, now as usual, we know first ray is parallel to principal axis, and after reflection passes through focus. Second ray is going to hit the surface at a, that is a reflecting surface of the mirror at P, and is going to diverge like this. So very clearly if I draw, and this is, now this diverging ray, this is incident ray, reflected ray, incident ray, reflected ray, and this is incident ray, and it is reflected ray. And if this reflected ray and both the reflected rays, if I extend back forth like this, if I extend back forth the dotted lines, they are going to meet at one particular point where here at this particular point the image is formed, and the image is erect, okay, virtual, enlarged. Virtual, erect, and enlarged image is formed. Okay, that is here. Orientation of the image or nature of the image is virtual, erect, enlarged. Virtual in the sense image is formed in the mirror. Okay, that is behind the mirror or within the mirror. That is virtual, erect, and enlarged image is formed. This is the orientation, and this is a value of magnification, and even we done with the image distance. So magnification no units, please remember this. And image distance 30 centimeter we got, and the image ray diagram for the respective problem is like this according to the results of image distance, and already we know the object distance. Okay, and the orientation of the image is virtual, erect, and enlarged. I hope you all understood this. Okay, next we'll be doing the problem, one problem related to convex mirror. Now I would like to write the problem on the board, then I will explain even the problem related to convex mirror. Now, an object is kept at a distance of, an object is kept at a distance of uh, that is, wait, 5 centimeter in front of a convex mirror, of focal length of focal length 20 centimeter. 20 centimeter. Calculate the position and nature of the image formed, and nature of the image formed. Okay, this is a problem. Now an object is placed at a distance of 5 centimeter in front of a concave mirror of focal length 20 centimeter. Calculate the position and nature of the image formed. Even we can calculate magnification also. Magnification. Okay. Now, according to the given problem, the data is distance of the object distance. Okay, u is equal to minus 5 centimeters. I am taking negative sign based on sign conventions by applying the sign conventions. Now, in front of a convex mirror of focal length 20 centimeter. Now, this is a convex mirror. You know, convex mirror is a diverging mirror, and this is a pole of the mirror, and for example, this is a focus, this is center of curvature. Now, an image 20 centimeter, listen, the image formed, this is a problem, and an object is kept at a distance of 5 centimeter in front of a convex mirror. Now the distance of the object is 5 centimeter, then we consider this one is object, for example candle, and the focal length of the mirror is 20 centimeter. That is from here to here, the distance focal length is 20 centimeter. This is a positive value. Now, he has to find out image distance, nature of the image, we can write, and even the magnification also we can find out. Now, that is object distance is u is equal to minus 5 centimeter, focal length. Focal length f is equal to positive value according to conventions, that is 20 centimeter. You have to find out v value. What is the v value? Then that is mirror formula. That is 1 by f is equal to 1 by v plus 1 by u. Now, focal length is how much? By substituting the focal length, that is plus 20, simply writing 20 is equal to 1 by v. How to find out? V plus 1 by u is how much? That is minus 5. According to conventions, u is minus 5. Now 1 by 20, bring this before that, 1 by v plus into minus 5. Next, after this 1 by 20, bring this 1 minus 1 by 5 to this side, it will become plus 1 by 5 is equal to 1 by v. Now, after this 1 by 20 plus 1 by 5, then you have to take the LCM. LCM will be, that is 25. If you take LCM, it will become 5 4 ja, 5 1 ja. LCM is 20. Okay, for information sake, I have written the values there. Okay, that is, this is a 20 LCM. 20 will go in 20 one time. That is 1 plus 5 will go in 24 times. That is 4 is equal to 1 by v. 1 plus 4, 5. 5 by 20 is equal to 1 by v. If you take the reciprocal, that is 1 by v is equal to 5 by 20. then V is equal to 20 by 5. 5 1 ja, 5 4 ja, that is 4 centimeter. That is image distance. Image distance is positive means I told already in the previous explanation when you are applying sign conventions. If the image distance is a positive, then the image is automatically the virtual image. Then you have to understand that. Okay. Next, you have to find out magnification. Copy up to this particular explanation. Then I will proceed further. Uh, Next, u already I said, that is I'm writing all the values, that is u is equal to 5, that is minus 5. V is equal to how much we got, 4 centimeter, this is minus 5 according to convention. And we have to find out now what means magnification. So magnification formula, magnification m is equal to, okay, image distance by object distance, formula m is equal to minus v by u. So m is equal to minus v by u. M is magnification, v is image distance, u is object distance. Now m is equal to minus sign and 4 by how much? This is minus 5. Now m is equal to minus minus gets cancelled, 4 by 5. Okay, then it will become 0.8 magnification. No units. It will become 4 by 5 means 0.8. Okay, that is 0.8 is the magnification. Now we know what is already object distance, we got image distance, even we got a magnification. Now how the ray diagram will be and how the orientation is. Okay, this is a pole and focus, this is a center of curvature. Now here, for example, object is placed here. Okay, now as usual, incident ray is parallel to principal axis. After reflection, it diverges, and divergent ray extend back forth, passes through focus, and second ray, if it is comes in contact with the pole, that is, it reflects at pole means it is going to bounce back like the incident ray. This is a reflected ray, and extend this one back forth. Now here the image is formed. What type of image it is? Virtual, erect, diminished, formed between pole and focus. Okay, orientation or nature of the image is virtual. Okay, erect, diminished, formed between what? Pole and focus. Virtual, erect, diminished, formed between pole and focus. Remember one thing, convex mirror always forms virtual images. Convex mirror always forms virtual images, and that too, they are diminished images. Okay, in one case it is highly diminished or point sized if the image is formed at focus and the object is at infinity. In that case, the object is at infinity, image is formed at focus, that is highly diminished or point size. Okay, formed at focus. Now here in this case, the object is distance is 5 centimeter. According to conventions, it is minus 5. Image is 4 centimeter. And the focal length, as usual, we know the respective value has given. We already know that. And this is a way to do the problem related to convex mirror when the respective data is given. I hope you all understood. And subscribe my channel for more videos and comment